right, welcome back to the Learning Happy Hour. My name is Luke Teeters. I am a systems engineer for Palo Alto Networks covering major accounts.
And I am Patrick Branley. I am a security training engineer covering our partners.
Awesome. So today we're going to come at you with a use case using our built-in tags in PanOS. I'm going to come with one use case. Patrick is going to have a second use case with two different results. So I am actually running PanOS 10.0. We just recently released that to the wild, and Patrick is actually running PanOS 9.1. So a little bit about my use case is I'm going to be leveraging the built-in actions in PanOS to tag a destination that fails to be decrypted. So Patrick, what's your use case going to be?
So I'm going to leverage the built-in action to quarantine potentially infected hosts.
Awesome. So this is something that is built into PanOS that anyone can leverage. And basically, we're just looking at the logs. We create a filter, and we basically match on the filter and say, if we see this, let's go ahead and take a built-in action. Let's go ahead and tag the destination or the source IP. We can do a duration. Do we want it tagged forever? Do we want to tag it for an hour? So, basically let your creative mind wander. Anything that you see in the logs, we can go ahead and tag on. So I'm going to go ahead and share my lab firewall here. So this is PanOS 10.0, and I went ahead and installed it on my PA220 here in my home lab. So to start off this use case, I'm going to go ahead and navigate to the Objects tab and go to Tags. As you can see, I have a tag called decrypt-air. I'm going to open it up, and as you can see, I added red-orange color, and I just put SSL forward proxy air under comments. But notice it is decrypt-air. Awesome. So let's go ahead and go to address groups, and let's take a look at this dynamic address group that I created called decryption bypass. And as you can see, I'm looking for decrypt-air tag.
Okay.
All right, so now this is going to navigate to the log forwarding of my firewall here. And as you can see, I have a log forwarding profile created. Let's go ahead and take a look. I went ahead and created an entry here called decrypt-bypass. Let's go ahead and open it up. And as you can see, I'm actually looking at the traffic log type, and I built a filter. This filter says if session end reason equals decrypt unsupported parameter, or session end reason equals decrypt-air, or session end reason equals decrypt cert validation. So if any of these match, and actually I can do this little drop down in my filter builder here and actually look at the live logs on this firewall.
Okay.
It's going to go ahead and do the search, and as you can see, I have some matches. So this is good. My filter looks good. This is where the magic happens. Built-in actions. So right here, I went ahead and created decrypt-bypass, and if we go ahead and hop in there, remember I mentioned my use case is to tag the destination address. So imagine a workstation tries to hit something on the internet. I'm decrypting all my traffic, and for some reason, one of those session end reasons occurs, right? Decrypt error. Well, I would like to add a tag to the destination address of decrypt-air, and as I already showed you, decrypt-air is in a dynamic address group, and more on that in a moment.
Okay.
So the timeout I have set for 15 minutes, but you can actually set this to 0 for infinite. You can set this for 60 minutes. You could set this for whatever duration you would like, and go ahead and click OK. The other nice thing here is we also have other actions we could take. So yeah, tagging the destination and bypassing it is great, but you'd have to go look at that often to see what's being bypassed decryption. What you could also do is add a HTTP GET to a integrated service, open a ticket. You could send yourself an email that this happened. You could do a SNMP trap. So you have other actions to basically notify yourself that this actually occurred. Basically, what Patrick and I are showing you here is, something happened identified in the logs, and we're going to take an action to either exclude it from decryption or go ahead and prevent it from hitting the internet. All right, so this looks good. So basically the configuration up to this point is we created a tag, a dynamic address group, and we went ahead and added a filter and a log forwarding profile, and we leveraged that tag for the built-in action. So now the other thing we need to do is go to policies. I'm going to go ahead and navigate to decryption policy.
Right. And
I will go ahead and show you what I have configured. So the first rule here, no decrypt, is basically saying inside to outside. If it's financial services, government, healthcare, military, and shopping, let's go ahead and do a no decrypt. I don't want to decrypt any of these URL categories.
Right. And that the PCI, all the ones we're not supposed to be looking at, right? So.
Yeah, exactly. And actually, this is part of our best practice guide. This second decryption policy is decrypt-bypass, and as you can see, it's also set to no decrypt action. But look what I'm referencing: decryption-bypass. This is that DAG, right? Dynamic address group, otherwise known as DAG. Below that is, this is the actual decrypt. So decrypt the lab, and I actually have decrypt home, but I'm just referencing one of my devices here on the network, my iPad. Okay, so basically I'm saying, again, if I'm on the inside going to the outside and I'm going to one of these destination addresses I tagged, let's go ahead and exclude it from decryption. Okay?
Okay.
So what I'm going to do is navigate back to objects, navigate back to address groups, and I'm going to show you addresses. There's no members right now of this dynamic address group. So on the side here, I'm actually going to visit a site that has a broken, it's basically going to trigger a decryption error. So I'm going to go ahead and go there now. Awesome. So let's go ahead and navigate to addresses here for more. And as you can see, I tried to visit a site and it was tagged. It's now excluded. It's a registered IP. I think I had it set for 15 minutes, but as of right now, this address will not be decrypted. So any of my users trying to go to this resource, it's actually not going to be decrypted. And the reason why is, as you saw in my filter, something happened for session end reason. It was probably decrypt error or something like that.
Right. One of the filters you put in there, because there was multiple. So. Yeah.
So that's really it. I mean, this use case I've seen large companies leverage. The reason why is getting to a full decryption is hard, right? You can't just turn on decryption and everyone be happy. When you turn it on, it's going to be a phased approach. And even if you start decrypting specific user groups or specific subnets, you're going to run into problems eventually based on certificate pinning, based on different things.
Yeah, if you've ever had to build that, you know the pain. It just, things are going to break and you have to kind of sift through it. So this would be very helpful in giving you exactly which ones are having the problem, which destinations. So I think it would be very helpful.
Exactly. So I'm going to go ahead and stop sharing, and we're going to have Patrick go ahead and share his lab, and he's going to walk us through his use case.
Okay, so before I go to the firewall, I just want to review the sinkhole operation, right? So let's say you have an infected host on your network, right? So we can see over there on the left side, infected host A. Now, infected host A wants to talk to the command and control host that's on the top right, dfb.7rz.ru, which sounds sketchy, right? So what infected host A is going to do is send a query to be able to determine what the IP address is of this particular domain. Now, the reason for this would be that this name could change IP addresses to be able to avoid being part of a list, right, of known malicious IP addresses. So it has to rely on DNS, right? So it's going to send this query to the local DNS server. Well, the local DNS server doesn't know what dfb.7rz.ru is, so it's going to send its query out to the remote DNS server, which we can see is right there below the C2 host name. So it sends its query. Well, the firewall is going to see that it's trying to query a malicious domain. So the firewall has a record of malicious DNS signatures. So when it detects this, rather than send it out to that remote DNS server, we can give it a sinkhole address, which could be anything. And it's represented here by 1.2.3.4, but it really is whatever we want it to be. So what the firewall does in effect is become a proxy for DNS, and it sends the sinkhole address in this case. It can also block, it can do other things, but in the case of sinkhole, it's going to send an address back, which will then inform the local DNS server the address is actually what the firewall tells it it is, so that the infected host receives the wrong IP address and cannot contact the host it's trying to contact. So for my use case, I'm not trying to determine destinations. I want to quarantine the source. So I want to take the infected hosts, potentially my network, and put them in a group and control their traffic until I have a chance to go and take care of whatever, remove whatever malware is on it. Okay, so now we're looking at my firewall running PanOS 9.1. And the first place I'm going to go is objects. Okay. Now I've got a very basic configuration on this firewall allowing traffic out. And I've configured, as you can see here, a anti-spyware profile that I will add to my security policy role here. But first, I want to go to my address groups. And I'm going to create a dynamic address group. So we'll call this infected hosts. And then I'm going to change it to dynamic, just like we saw before. And then I'm going to add a match criteria. In this case, I'm going to add the infected host tag. All right, so that's the first thing. Then I'm going to come down here to, I already have my tags built. So I'm going to come down now to my log forwarding. And I'm going to add a log forwarding profile. And we'll call this infected host as well. That's fine. And then down here, I'm going to add my tagging. So what I'm going to do is we'll call this tag infected host or something of that nature, just so we can differentiate. I'm going to use the threat log. And then I'm going to filter, and I'll build my filter for a very specific thing. I just want to use an action that equals, as it pulls up, sinkhole. And then I will add it here. All right, now I can view the filtered logs, but I probably won't see anything yet because I haven't actually activated the sinkhole yet. So for me, it'll have to be after the fact. So I'm going to hit OK. So now I have that built. Now I got to go to my built-in actions. So I hit add, and I'll call this, we can say this tag infected host, but that's all right. It can have the same name. All right, now I'm going to do source address, right? So I'm going to say source, and then I will choose local, and then I'm going to choose that tag, which is infected hosts. All right, so now when it sees the dynamic address group, it sees the sinkhole, whatever gets sinkholed will be tagged with this tag, and then it should move it to that group, right? So the last few steps here is that I need to build my sinkhole. So I'm going to go back into anti-spyware, and I'm going to come down to this one I've already pre-built, and I'm going to move to this tag of DNS signatures. Now, I need an external dynamic list, right? So I'm going to grab one that I've already built called DNS sinkhole. I'm going to set the action to sinkhole. And for the IP that I want to do, I'm not really worried about IPv6 in this lab, so I'm going to use v4. And I'm just going to leave it as sinkhole.paloaltonetworks.com, okay? And we'll see that address when it comes up later. So now that I have sinkhole turned on, the last steps are going to be go to my policy. I'm going to go into my egress outside, which is my basic rule. I am going to add the profile of anti-spyware. And then I'm going to add my log forwarding for infected hosts. Okay. Now, the last step is I want to create a rule. So I'm going to go ahead and clone this rule and put it on the top. And I want this rule to effectively quarantine my devices. Now, there's a lot of ways to do this, right? So I could call this block infected devices, quarantine infected devices, or whatever I want to call it. But what I want to do, in fact, I can even change the tag here to infected hosts, right? So inside source address will be my dynamic address group, infected hosts. Destination outside any is fine. Application any. Now I could leave it as application default, but since I'm denying it, I could do any. And then I will actually turn this off on this one because I don't need that. Go ahead and deny this. And actually, I don't actually need that as well here. So now I'm just going to make it a simple deny rule. Again, I don't have to be so broad. I could make this so it can't talk to critical servers or other critical services. I could get really granular about it, but for our purposes, let's just block it outright, okay? All right, so now that I have this set up, I will hit commit. Now, while we're waiting for the commit, the external dynamic list, I actually just have a very basic list here. So if we look at the list, I just have 3 addresses near, actually taken from an actual malware list. But just for testing purposes, there they are, okay? So when this is done committing, I can then go do an NS lookup, and I can look to see what it tells me is the IP address of that domain, okay? And it should be the one that we tell it through sinkholing, right? All right, so the next step then would be to test it, right, using NS lookup. So we can take one of the 3 addresses on my EDL here, right? So gulfsource.us, tourindia.in, or VIP projects. So let's just do gulfsource.us. All right, so okay, now we can see here that we see that it says sinkhole.paloaltonetworks.com and 72.565.111, which is the sinkhole address of Palo Alto Networks. Now it has an alias of gulfsource.us. So we could also do the other one, which is tourindia.in. So if I can type, we will. And now we see that it's timing out, right? So rather than being able to do a DNS lookup, now it's just blocked outright. Why is that? Because that's what we told it to do. And I can look right here and see the value of my infected hosts here. And there we see that the device that I'm using, 192.168.1.20, is now registered as a source address in this infected group's DAG. And it is, of course, denying that traffic. So that's a great test right there. Now to see it as well, we can look at the monitor, look at the threat log, and we can see that there's the one sinkhole that happened, right? The Gulf source, right? If we wanted to see the Tour India, we'd have to really look at the traffic log to see it blocked, right? Because now it's just a blocked, outright blocked traffic. As a matter of fact, all my traffic is blocked, so this workstation is effectively quarantined, can't go anywhere. So that's how you do it.
Awesome. Hey, there's one other thing I wanted to mention, Patrick. So if you navigate back to your spyware profile,
okay,
there are objects and spyware, anti-spyware, yeah. Take a look at the lab AS.
Okay.
And if you go to the DNS signatures, so Patrick did something really interesting. He actually added an external dynamic list for these specific use cases, but there are 2 other address lists above that. One is the content DNS signatures that is included in your daily 24-hour update on the firewall. If you are a DNS security subscriber, that is the list below in the center there. And that is a real-time list where PanOS actually queries every DNS query real-time on the wire to the DNS security cloud service. So those are actually hosted by Palo Alto Networks. Those are all threat intel lists. So just wanted to clarify that Patrick's list was an EDL, which gives you the ability to ingest your own threat intelligence.
Right. And actually you bring up a very good point that My EDL is a very basic example and not the kind of EDL I would want to use, because I would have to keep it up to date because it's just a text file. So yeah, in the real world example, we would want to use actually dynamic lists, whether it's coming through Palo Alto Networks or maybe some kind of third-party source that updates it regularly, so the firewall can be updated rather than manual update, which would be, well, terrible, to be quite
Yeah,
honest.
exactly.
So
And we also have the MindMeld open source project, which can actually correlate a bunch of different lists and feed it to an EDL. And for those of you who don't know what an EDL is, it's an external dynamic list that is hosted on HTTP or HTTPS that can be digested by the firewall.
right, so you can build different types. There's IP lists, there's URL lists, there's domain lists. So quite a bit of use. That's a whole other episode, I suppose.
Yeah, that's a whole other episode.
That's quite a bit of use cases for external dynamic lists, and
Sure.
also a way to expand your threat posture by giving you many more resources. So
Yep. Yep.
all right.
Awesome. Well, thanks a lot for joining us today. Thank you, Patrick, for showing us this use case. I think this is something very useful for users of PanOS to understand these capabilities, because once you get the firewall in place, it's doing a traffic inspection, you're building your policies, you basically would like to start automating things. You don't want to just constantly respond to service desk calls that I can't get to this website because the decryption's failing, or you get the call to do incident response that a box was compromised. It was reaching out to a bad domain that could have otherwise been sinkholed and prevented.
Right.
So any other comments, Patrick? I think this about does it for us today.
I think so. This is kind of a fun one just because I love sort of the nerdy aspect of being able to automate and kind of take things a little further than just your basic blocking and and allowing of traffic. So this was a lot of fun. Glad. Hopefully it's very helpful for all of you out there, and gives you just another glimpse at some of the other capabilities that the firewall and the security platform has.
Awesome. Well, thanks, Patrick, and we'll catch you guys next time.
All right. Thanks. Take care and be safe.